Hi guys, let's look at this ASVAB test question that we have here. The question says, what is the sum of the prime numbers below? The numbers we have are 10, 13, 16, 25, 19, and 47. For us to be able to get this done correctly, first we need to know what prime numbers are. But in order to know what prime numbers are, we need to step back a little to understand what factors of numbers are. The factors of a number are those numbers that can divide a particular number without leaving a remainder. So if a smaller number can divide a larger number without a remainder, that means the smaller number is a factor of the larger number. Okay. Now, what is a prime number? A prime number is a number that has only two factors, 1 and itself. That means if a number has more than two factors, it is not a prime number. So among these numbers, we need to find out those numbers that are actually prime numbers. When we find them out, then we can add them together. Let's try the first one, 10. Is 10 a prime number? What are the numbers that can divide 10 without leaving a remainder? The first number is 1. The smallest factor of every number is 1. The largest factor of every number is the number itself. 1 is a factor of 10 because 10 divided by 1 is 10 without leaving a remainder, right? 2 also is a factor of 10. 10 divided by 2 is 5, no remainder. 10 is a factor of 10. So just by mentioning these numbers, we've gotten 4 factors of 10. 1, 2, 5, and 10. These 4 numbers are factors of 10. Therefore, 10 is not a prime number. Let's try out 13. Is 13 a prime number? Let's see. The smallest factor of 13 is 1. The largest factor of 13 is 13. Between 1 and 13, do you know of any number that can divide 13 without leaving a remainder? 2. Can 2 divide? No. 3, 4, 5, 6. None other number can divide 13 without leaving a remainder. Therefore, 13 is a prime number. So we have 13 here. Remember, we are trying to find the sum. Sum means addition. So we've gotten the first prime number plus, let's see if there's another prime number. 16. Is 16 a prime number? Let's see. 1 is a factor of 16. 16 is a factor of 16. But in between 1 and 16, let's see the numbers that can divide 16 without leaving a remainder. 2 can divide 16 without a remainder. 4 can divide 16 without a remainder. And 8 can divide 16 without a remainder. In total, we have 5 numbers that can divide 16 without a remainder. A prime number only has 2 factors. Therefore, 16 is not a prime number. What about 25? The smallest factor of 25 is 1. The largest is 25. Between 1 and 25, do we have another factor? Yes. 5 times 5 is 25. Therefore, 5 is a factor of 25. 25 has 3 factors, 1, 5, and 25, which means 25 is not a prime number. What about 19? The smallest factor of 19 is 1. The largest factor of 19 is 19. Between 1 and 19, there are no other numbers that can divide 19 without leaving a remainder. Therefore, 19 is a prime number. Let's try the final number, 47. Is 47 a prime number? The smallest factor of 47 is 1, and the largest is 47. Between those two numbers, there is no other number that can divide 47 without leaving a remainder. If you know about any number that can divide 47 without leaving a remainder apart from 1 and 47, please leave it in the comment section. But I know that there is no other number that can divide 47 without leaving a remainder. Therefore, 47 is a prime number. So among all the numbers we have on this list, these are the only 3 numbers that we're expected to add together. So let's add them. Remember, the question says, what is the sum? So we're supposed to add them. Okay. 13 plus 19, this 32. 32 plus 47, this 79. This means the correct answer to this question is option C. Very simple. Hope you understood the lesson. If you did, don't forget to like the video, share with your friends, and follow for more maths content. See you in the next video. Bye.